Hello students, welcome to the class. So in the previous class, we have discussed about oxidation, reduction, and what is redox reaction and what are the applications of redox reaction. Now moving to what is an oxidizing agent and what is a reducing agent. It is basically said to be acceptor of electrons and reducing agent is donor of electrons. So let us see what do we mean by it. Okay, we need to understand this in very proper manner. Then only we'll understand the oxidation and reduction and therefore redox reactions. The role of an oxidizing agent. Oxidizing agent, it is called as oxidant, oxidizer in a chemical reaction is to gain electrons. They are highly electronegative. Once they gain electrons, these substances are reduced. So an oxidant is also known as electron acceptor, acceptor of electrons. Example, nitric acid, halogens, etc. Then the role of reducing agent, reductant in a chemical reaction is to lose electrons. Once they lose electrons, these substances get oxidized. A reductant is also known as electron donor. Example includes sulfide compounds and earth metals. Okay, let us try to understand them by considering examples. Okay, fine. So oxidizing agent. Oxidizing agent. For that, we need to remember what is oxidation, and we know what is oxidation. Oxidation is what? It is loss of electrons, OILREG. That means oxidation, there is loss of electrons, reduction, there is gain of electrons. Oxidizing agent means what? It should help the substance to undergo oxidation, yes or no? So oxidation is loss of electrons. That means oxidizing agent helps the substance to lose electrons. So how it helps the substance to lose electrons? It will take the electrons from the substance. Therefore, oxidizing agent, it is an atom or an ion or a molecule which gains electrons, and helps in oxidation. Helps in oxidation because oxidation means loss of electrons. So electrons have to be lost means some substance, some atom or ion should gain those electrons. Then only we call it as oxidation. Yes, and thereby it reduces to low valency state. It decreases to low oxidation state. So it will gain electrons means what? Oxidation state will decrease. So while the substance which loses electrons, reducing agent helps in reduction. Means what? Reduction is gain of electrons. So if it wants electrons, so substance has to gain electrons. From where it will gain? It will gain from reducing agents. So reducing agents will lose electrons and help in reduction. They help in reduction, and thereby it increases to high oxidation state. It increases to high oxidation state. That is called reducing agent. Or you can also define as an oxidizing agent is a substance, the oxidation number of whose atom decreases. Oxidation number decreases, then it is oxidizing agent. If that atom's oxidation number decreases, then it becomes oxidizing agent. If that atom's oxidation number increases, it becomes reducing agent. So important oxidizing agents are examples for oxidizing agents. We can say the important oxidizing agents are they might be molecules which are made up of electronegative atoms. Like for example, O2 acts as oxidizing agent, ozone acts as oxidizing agent, halogens act as oxidizing agents. Yes, so they act as oxidizing agents. Second, compounds having an element which is in highest oxidation state. For example, KMnO4 acts as oxidizing agent, K2Cr2O7 acts as oxidizing agent, H2SO4 acts as oxidizing agent, CrO3 chromic oxide acts as oxidizing agent, nitric acid acts as oxidizing agent, then you have ferric chloride, then you have mercury chloride, KCl4, potassium chlorate acts as oxidizing agent, carbon dioxide acts as oxidizing agent, SO3 acts as oxidizing agent, even hydrogen peroxide act as oxidizing agent. Means what? They are acting as oxidizing agent means they help in oxidation. How? By gaining the electrons. So they will gain the electrons and help in oxidation. Yes, they will gain the electrons and help in oxidation. Is that right? Important reducing agents. Important reducing agents are, for example, metals. Metals which are electropositive. They help in reducing, they act as reducing agents. That means, example, sodium acts as reducing agent, zinc acts as reducing agent, iron acts as reducing agent, aluminium, etc. All these act as reducing agent. Then some non-metals also act as reducing agents. Some non-metals also act as reducing agents. For example, carbon acts as reducing agent, H2 acts as reducing agent, sulfur acts as reducing agents. Even hydra acids, they are also called mineral acids. They act as reducing agents like HCl, HBr, HI, then hydrogen sulfide. These all act as reducing agents. Few compounds with lower oxidation state, like for example, say FeCl2, then SnCl2, these all act as reducing agents. Hydrides, metallic hydride, sodium hydride, lithium hydride act as reducing agents. In metals, the strongest reducing agent is, the strongest reducing agent in metals is lithium. Lithium is the strongest reducing agent in solution. Okay, and cesium is the strongest reducing agent in absence of water. Yes, so these all act as reducing agents. Now, how to verify? Test for oxidizing agents and test for reducing agents. Okay, so I hope these are understood. Examples I have taken. Okay, when we discuss reactions, we'll come to know that. So what are the tests for oxidizing agents? Tests for oxidizing agents. Yes, aqueous solutions of oxidizing agents. If you take aqueous solutions of oxidizing agents, that is dissolving oxidizing agents in water, when you treat them with hydrogen sulfide, like for example, oxidizing agent, aqueous solution, when you treat it with hydrogen sulfide, what will happen is it will form sulfur. Yes. So oxidation is what? Removal of hydrogen. So has this oxidizing agent removed hydrogen from H2S? Yes. So it is oxidizing agent. So it itself has taken hydrogen. Okay. Therefore, we say oxidizing agent helps in oxidation and itself gets reduced. Yes, it reduces or no? And itself gets reduced. So it helps in oxidation and itself gets reduced. Whereas reducing agent helps in reduction and itself gets oxidized. Please do remember it. Itself gets oxidized. Okay. So here it is forming sulfur. How do we get to know? It will form milky yellow precipitate. This is the test for oxidizing agent. Even when this aqueous solution of oxidizing agent is treated with potassium iodide, yes, when it is treated with potassium iodide, it will give dark blue color. This is confirmation that the taken compound is an oxidizing agent. It will give dark blue color. Third is, when you take this oxidizing agent solution and treat it with ferric ions, what happens is Fe+2 ions, it will get converted to Fe+3. And when it is treated with CNS, ammonium thiocyanate solution, we get FeCNS3. This is dark red color. Yes. So these are all what? These are all tests for oxidizing agents. Then what are the tests for reducing agents? Yes. The simple tests involve aqueous solutions of reducing agents. You take aqueous solutions similarly as we took for oxidizing agents and you add acidified aqueous solution of reducing agents react with acidified KMnO4, potassium permanganate, and the color disappears. The color of potassium permanganate is pink. Later it becomes colorless. So we say it is reducing agent. Similarly, take aqueous solution of reducing agent and treat it with K2Cr2O7, potassium dichromate. It will get converted to green color. It will get converted to green color. So these are nothing but tests for oxidizing and reducing agents. Tests for oxidizing and reducing agent. So oxidizing agent is what? It gains electrons and helps in oxidation, and therefore it reduces to lower oxidation state and itself gets reduced. So oxidizing agent helps in oxidation by gaining electrons and itself gets reduced. Reducing agent helps in reduction by losing electrons and itself gets oxidized. So once we know this oxidizing agent and reducing agent, we need to know how to calculate the equivalent weight. In the first topic itself, we have seen this of oxidizing agent and reducing agent. Okay, so let us see how we can calculate equivalent weight of oxidizing agent and reducing agent. See, equivalent weight of a substance, whether it is oxidant, that is oxidizing agent, or reducing agent, that is reductant, it is equal to, I can write here, equivalent weight of oxidant. Let me say oxidant is equal to, it is the ratio of molecular weight divided by number of electrons. Oxidant will do what? It will gain. So number of electrons gained by one molecule. This is the equivalent weight of oxidant. This is how you calculate it. Similarly, equivalent weight of reductant is equal to, again, molecular weight of that molecule, of that reductant. So molecular weight divided by number of electrons. What does reductant do? It loses. So number of electrons lost by one molecule. Yes, or you can say in general, change in oxidation number. So if electrons are gained, oxidation number becomes from 0 to -1, -2, -3, it decreases. If electrons are lost, from 0 it becomes +1, +2, +3. So that is how we calculate the equivalent weight. For example, now suppose I want to calculate the oxidation equivalent weight of, let me say, Cr2O7 -2, it is forming Cr +3. So in this case, the oxidation state of Cr is, here it is +6. So from +6, it is becoming +3. From +6, it is becoming +3. Means what? How much is the change? It is 3. So 3 is what here? 3 electrons are gained. Yes, 3 electrons are gained. So change in oxidation number per atom is 3 electrons. But chromium, there are 2 atoms. Therefore, I will do 3 into 2. How much? Equal to 6 electrons. Therefore, how do you find the oxidation state? Molecular weight of chromium divided by 6. Molecular weight of chromium divided by 6. Understood why 6? Here 3 electrons. But there is 2 chromium atoms. Therefore, 3 into 2 is 6. So therefore, divided by 6. This is how we calculate the equivalent weight. Yes, this is very important. Equivalent weights of the oxidizing agents. Equivalent weights of the oxidizing agents as well as reducing agents. Okay, fine. So let us see further. So can you see here? So oxidizing agent will do what? It will gain the electrons. It will get reduced. Reducing agent will do what? It will lose electrons and give to B. It will give to B. Okay. So example is given here. Fe2O3 plus 3CO gives 2Fe plus 3CO2. Now see, Fe2O3 is losing oxygen. So there is removal of oxygen and it is forming Fe. So this is reduction. So loss of oxygen. CO is gaining one oxygen and becoming CO2. So it is oxidation. Now if I consider reduction process, suppose if I consider this reduction process, it is losing oxygen. Who is helping in reduction? CO is helping in reduction. So it helps in reduction, correct? How it is helping in reduction? By taking the oxygen. So is it taking the oxygen? Yes. So when it is taking the oxygen, can I say it is itself getting oxidized? It itself getting oxidized. Understanding? So CO is nothing but it is a reducing agent. It is reducing agent which helps in reduction of. So I can say CO is reducing agent, helps in reduction of Fe2O3 to Fe, and it itself gets oxidized. It itself gets oxidized. Yes. Okay. On the other hand, I can say like this. If I speak about oxidation of CO, CO is gaining oxygen and getting oxidized. So CO is becoming CO2, it is oxidation. Who is helping him in oxidation? So from where this carbon monoxide is getting oxygen, it is getting oxygen from Fe2O3. Therefore, I can say Fe2O3 is oxidizing agent. It is oxidizing agent. Why? Because it is helping in oxidation. So when it is helping in oxidation, it is giving its oxygen, correct? And itself getting reduced. Itself getting reduced because it is losing oxygen. Removal of oxygen from oxidizing agent. Understood? So oxidizing agent means what? Oxidizing agent means helps in oxidation, but itself gets reduced. Reducing agent helps in reduction, but itself gets oxidized. Yes. So you can see here strong oxidizing agents and strong reducing agents. So when I speak about oxidizing agents, I come across certain terminologies. Yes. So factors affecting oxidizing nature are of the oxidizing agent. Oxidizing agents, if you see, they normally exist in highest possible oxidation states. Highest possible oxidation states. Okay. So, and they have the strong tendency to gain electrons. They will have the strong tendency to gain electrons and therefore get reduced. They will get reduced. Right? Okay. Atoms and molecules having strong affinity towards electrons. So which will gain electrons? Which will have strong affinity towards electrons. They will gain electrons. They are considered to be good oxidizers or good oxidants, or you can say good oxidizing agents. So stronger the electron affinity, I can say, stronger the electron affinity or stronger the electron gain enthalpy, greater is the oxidizing power. Greater is oxidizing power. Yes or no? Greater is oxidizing power. So electron affinity towards electron should be more. So if you consider elemental fluorine, it is the strongest elemental oxidizing agent. This is due to the fact that fluorine is most electronegative, correct? So since fluorine is most electronegative element in the modern periodic table, therefore it exerts strongest attractive force on the incoming electron, correct? Yes or no? So amongst all the elements, if you compare, in fact, oxidizing power of diatomic fluorine, this is atomic. If you consider diatomic fluorine, is stronger enough to cause metals such as quartz and all to burst into flames. A few more examples of elemental oxidizing agents like you have oxygen, you have chlorine, ozone also acts as best oxidizing agents. So these oxidizing agents are elemental forms of second and third most electronegativities, oxygen, chlorine especially. Okay. Yes. So making them good electron acceptors, or you can say best electron acceptors. So this can be explained by standard electrode potential. Standard electrode potential. So this provides the insight into the oxidizing power. And you can see this table, it is based on the standard electrode potential only. Yes. So some compounds that exhibit large oxidation states, they are also considered as good oxidizing agents. Is that clear? So this is all about oxidizing agents. All about oxidizing agents. Okay. Fine. And this side, what you're seeing, they are reducing agents. So in this direction, they act as best reducing agents. So lithium acts as the best reducing agent. What are the applications of oxidizing agents? Halogens are best oxidizing agents. Oxygen is best oxidizing agent. H2O2 is best oxidizing agent. Yes. So they are helpful in bleaching of fabrics, purification of water. Combustion of fuel involves the use of an oxidizing agent. Storage of energy in the batteries. Vulcanization of rubber means what? What we do is natural rubber does not have that greater strength of elasticity. Therefore, rubber is mixed, natural rubber, it is mixed with sulfur or sulfur containing compound in order to increase the strength and elasticity of the rubber. That is called vulcanization of rubber. Yes, that is also oxidizing agent. Oxidizing agents are also vital to many biological processes such as metabolism and photosynthesis. In one of our previous video only we have seen where we were discussing the redox reaction applications. Many organisms make use of electron acceptors, or you can say oxidizers, to collect energy from redox reactions, such as in the process of hydrolysis of glucose. Now, characteristics of reducing agents. Okay. So what are these reducing agents? Just now we have seen reducing agent loses electrons because it helps in reduction and itself gets oxidized. So a reducing agent is one of the reactants in an oxidation reduction reaction which reduces the other reactant by giving out electrons. Okay, it will lose electrons. That's it. What are the characteristics? Reducing agents tend to give away electrons. They tend to lose electrons. The metals of S block in the periodic table are said to be good reducing agents. The reducing agents, after losing electrons, get oxidized and also cause the opposite reactant to get reduced by supplying the electrons. All the good reducing agents have the atoms with low electronegativity or good ability of an atom or a molecule to attract the bonding electrons and species having very small ionization energies. That is metals. Their atomic size is large, therefore their ionization energies are low, therefore they will lose electrons very easily and act as best reducing agents. You can see here, we had seen. Yeah, in this side we have reducing agents. See, there are metals only. And lithium at the bottom is the strongest reducing agent because of large because of atomic size and what? And ionization energies. When some substance is oxidized, means what? It is said to lose electrons. And the substance which receives electrons is said to be reduced. Therefore, our reducing agent, what is the work of reducing agent? Reducing agent does what? It will help in reduction. That means it will help in reduction means what? It will lose electrons. Yes, and itself gets oxidized. If the substance has strong tendency to lose electrons, then it is said to be a strong reducing agent, since it will reduce the other substance by donating the electrons. Now, strong versus weak reducing agents. The stronger the reducing agent, the weaker is the corresponding oxidizing agent. Correct? Yes. Stronger the reducing agent, weaker is the oxidizing agent. Fluorine gas is known to be stronger oxidizing agent, whereas F minus is said to be weaker reducing agent. Yes. So fluorine, when it becomes F minus, fluoride ion, we call it as a weak reducing agent. We also know that weaker the acid, stronger is the conjugate base. Similarly, weaker the oxidizing agent, then more stronger is the corresponding reducing agent. So fluorine, it is the strong oxidizing agent. But if you take F minus, it becomes weak reducing agent. It's like a conjugate acid-base pair. Conjugate acid-base pair. Yes. So you can see here. F2 is a strong oxidizing agent, correct? It helps in oxidation because it will lose electrons, helps in oxidation. Strong oxidizing agent helps in oxidation means what? It will lose electrons very easily. So it will gain electrons. So when it gains electrons, it becomes what? F minus. So it is a weakest reducing agent. Na plus, weakest oxidizing agent, but when it gains electron, it becomes a strongest reducing agent. Strongest reducing agent. Okay, now important points. Due to the smallest standard reduction potential, lithium is the strongest reducing agent. It decreases another substance when something is oxidized, becoming a reducing agent. Lithium is therefore the most powerful reducing agent. The highest oxidizing agent is the weakest reducing agent. The species that are lowered in redox reaction are oxidizing agents. When we come to the examples, you will understand it much better. Okay. When hydrogen gas is carried over warm metallic oxide of copper, lead or iron, etc., what it will do? It will remove oxygen from them and therefore lower them to respective metals. Therefore, what is hydrogen? It is removing oxygen. So it is helping in reduction. Yes, removal of oxygen. So here are the examples. Na solid plus Cl2 gives NaCl. So what is happening to Na there? You can see Na here oxidation state is 0. In NaCl it is +1. That means Na is losing 1 electron. There are 2 Na atoms, so it will lose 2 electrons. To whom it is going to lose? So this is what? This is oxidation. So what chlorine does? It will take those 2 electrons. From 0, it will be becoming -1. So it will take those 2 electrons and become -1. That is, it is reduction. Yes. So these are the examples for oxidation reduction reactions. Similarly, Na plus oxygen is becoming what? It is becoming Na plus, that is twice, and then O2 minus. It is becoming an oxide. It is becoming an oxide. So Na is 0 here. It is becoming +1. And O2 is 0. It is becoming -2. So what Na is becoming? Losing 2 electrons. So it is oxidation. And this is reduction. Now to whom this Na is losing electron? So Na is undergoing oxidation. Who is responsible for it? Oxygen is responsible for it. Chlorine is responsible for it. Sulfur is responsible for it. Therefore, chlorine, O2 and sulfur are oxidizing agents. They are oxidizing agents. Yes, on the other hand, look in the other way. O2, chlorine is becoming from 0 to -1. So it is gaining electron. Who is giving that electron? Sodium is giving electron. O2 here is becoming -2. So oxygen is gaining 2 electrons to become -2. So it is getting reduced. Oxygen reduction is happening here. Who is helping him in reduction? It is sodium. Here also it is sodium, making it from sulfur with 0 oxidation state to -2. Therefore, sodium acts as what? Sodium acts as reducing agent. Reducing agent. And itself gets oxidized. Itself gets oxidized. Is that clear? It itself gets oxidized. Okay. So competitive electron transfer reactions. Before going to this, let us try to understand oxidation number. So far we have used it so many times, right? So what do we mean by oxidation number? Okay. Fine. Oxidation number. See, when we speak about oxidation number, it is nothing but charge on an atom produced. What is oxidation number? Charge on an atom produced how? Produced by either losing electrons or gaining electrons. Yes, gaining electrons. And you know this. So when an atom, there is 0 charge, when it loses electrons, it carries positive charge, +1, +2, depending upon how many electrons are lost. If it is a neutral atom, when it let me write it here. So when it gains electrons, it will become -1. So cation and anions, what charge is carried by those ions is nothing but oxidation number, or you can call it as oxidation state. You can denote it as oxidation number or oxidation state. Okay, oxidation number or oxidation state. Fine. So what do we mean by valency then? Or what is the difference between valency and oxidation state? So valency and oxidation number concepts are different. Okay. In some cases, mostly in electrovalent compounds, ionic compounds, valency and oxidation number are same. But in some other cases, they are different. So oxidation number is what? It is the charge on an atom produced by losing electrons or by gaining electrons. That is oxidation number. Valency is what? Valency is combining capacity. Combining capacity of atom of element. Yes, combining capacity of the atom of that element. That is nothing but valency. Okay, so oxidation number, let me make a distinction like this. Okay, so let me take here oxidation number and let me take here valency. Okay, so here we saw the definitions of oxidation number and valency. Charge on an atom produced by losing or gaining the electrons, and valency, it is the combining capacity of an atom of an element. Oxidation number, it may have plus sign, that is, it may have positive value, it may have negative value, it may have 0 also. Whereas valency of the element is usually fixed. Valency is fixed. For example, now you take Mg, yes, 0. When it loses 1 electron, it becomes what? Mg plus 1 electron. When Mg plus loses electron, 1 more, it becomes Mg plus 2, plus 1 electron comes out. So this is the, what you say, this is the oxidation state or oxidation number of magnesium. Oxidation state or oxidation number of magnesium. Whereas valency is what? Valency of magnesium is plus 2. That means its combining capacity is 2. So it is fixed. Valency is fixed. It will not change. It will not change. Now, oxidation number of an element. So no plus sign or minus sign we write for valency. When we speak about valency, we say 2 for magnesium, 1 for sodium, 1 for fluorine. We don't write symbol here. So oxidation number might change. It will have different values depending upon nature of compound which is present. Okay. Whereas valency of the element is usually fixed. Okay. Fourth point is that oxidation number may be a whole number. It may be a whole number or it may be fraction. It might be whole number or it might be fraction. Whereas valency is always a whole number. It is always a whole number. It cannot be fraction. It cannot be fraction. Oxidation number may be 0. Valency of the element is never 0 except noble gases. Except for noble gases, valency of the elements is never 0, whereas oxidation number can be 0. So this is the difference between oxidation number and valency. Oxidation number and valency. Is that clear? So oxidation number, it might charge on an atom produced by losing or gaining of the electrons. And valency, combining capacity of that atom. Okay, now when we are writing oxidation numbers, there is different nomenclatures. Okay, let me tell you what. So we'll discuss that also. So that when you are naming the compound also, you will not face any difficulty. Fine. Okay. See, first point is when an element forms 2 monoatomic cations. For example, let me say copper will lose 1 electron and forms U plus. And sometimes in some other compounds, it will lose 2 electrons and forms U plus 2. Understanding? So in this case, what is the oxidation number? Oxidation number is 1. Here, oxidation number is 2. Getting my point? So it will form different oxidation states. The 2 ions are distinguished by ending, you give certain number. How do you name this? We call it as copper, or its elemental name is cuprum, right? Therefore, how do we write the name? we use a suffix OUS or IC. We use these two suffixes. Now the question is, when do we use those suffixes? Remember, the suffix, that means after a word, the suffix OUS. The suffix OUS is used for cation with lower oxidation state. And the suffix IC is used for cation with higher oxidation state. So this Cu plus, according to this equation, according to this rule, I will call Cu plus as cuprous. Okay, and I will call Cu plus 2 as cupric. Understood? Lower is OUS and higher is IC. Similarly, one more example can I give? You have Fe plus 2 and you have Fe plus 3. It is not necessary that it should start from 1 only. So it can be, this is stable oxidation states for iron. So Fe plus 2, we call it as what? We call it as ferrous. Fe plus 3, we call it as ferric. I'll give you example also here. Example is, I have say compound of FeSO4 and one more compound is FeCl3. So in both the cases iron is there. How do you write the name? How do we write the name? For this, the name of the compound is ferrous sulfate. What does that mean? Ferrous means what? It is plus 2. And here I call it as ferric chloride. Understanding? Are you getting my point? So if it is lower oxidation state, we use the suffix OUS. Suffix means after the name of the element. If it is higher oxidation state, we use the suffix IC. Hg plus and Hg plus 2. So how do you use? This is mercurous. This is mercuric. Understanding? Mercurous and mercuric. Further, I can say Albert Stock, he proposed a new system known as Stock system. What he did here is he used Roman numerals written in parentheses, which represent the, so this is second way, he used Roman numerals written in parentheses into the brackets to represent the oxidation state. For example, Cu2O. The oxidation state of copper is 2. So how do you write it? So oxidation state is 2. So plus 2 if I say, it is a cupric oxide, correct? What Albert Stock did is, he called it as copper. What is the oxidation state? 2. Write in Roman numerals and then write oxide. This was Albert Stock method. Yes. One more example. You have FeCl2. What is it? Ferrous chloride, correct? I'll not write it as ferrous chloride. Sorry. How do we call Fe? When we are writing the compound name, we call it as iron only. So iron, what is the oxidation state? It is 2 and then chloride. Another example, FeCl3. How do we write it? According to Albert Stock method, iron 3 chloride. Otherwise, common nomenclature, this is called ferrous chloride. This is called ferric chloride. Common nomenclature, ferrous chloride. And this is ferric chloride. Ferric chloride. Is that right? Okay. Then rules for determining the oxidation state. What are the rules for determining the oxidation state? Now, how to find the oxidation state? The first point says that, yes, there are many rules. Please give proper attention. Okay. So we'll divide our table. Fine. So first one is, if there is a covalent bond between two same atoms. If there is a covalent bond between two same atoms. So the atoms are say AA, generally I've taken, and this is a covalent bond. And I hope you know, formed by mutual sharing of the electrons, correct? So between the two atoms, then the oxidation number of these two atoms will be 0. Both the oxidation numbers. So oxidation number of both atoms A will be what? It will be 0. It will be 0. This is first rule. Second rule, based on these rules only you have to assign. Okay. Bonded electrons, why it is 0? Because since if the bond is between, it is a covalent bond which is formed by mutual sharing. And since the bond is between two similar atoms, there is symmetrical electronegativity. So they are symmetrically distributed between the two atoms. Therefore, the bonded atoms will not acquire any charge. And therefore, the oxidation state will be 0. Example, you can take chlorine, H2, O2. Yes. So these are the examples. N2. So chlorine molecule, oxidation number of both chlorine atoms is 0. H2 molecule, oxidation number of both H2 atoms is 0. Oxygen molecule, oxidation number of both oxygen atoms is 0. Nitrogen molecule, oxidation number of both nitrogen atoms is 0. Next point, if the covalent bond is between two different atoms. Okay, if the covalent bond is between two different atoms, let me say I have atom A and B. And it is a covalent bond. Okay, covalent bond. It is covalent. Then electrons are counted towards more electronegative atom. Okay, so thus the oxidation number of more electronegative atom will be negative. So I can write it as A plus B minus. So you will consider the oxidation number of more, suppose B is more electronegative. So B is more electronegative than A. In that case, B will have minus charge, A will have plus charge. And total number of charges depends upon the number of bonds. So if it is single bond, I will write it as like this. If it is like this, suppose the two atoms are different and there is a double bond, then I will write it as A plus 2 plus B minus 2. This is how I write it. So oxidation number of less electronegative element atom, say A, will be plus 1 here. Here it is minus 1 and here it is plus 2 minus 2, which cancels out and becomes again plus 1 and minus 1. This is second rule. For covalent compounds, same covalent compounds 0, different covalent compounds more electronegative atom. If there is a coordinate bond, that means one atom will give its contribute its shared electron pair and both the atoms will share the electrons. Yes, then oxidation number of donor atom will be 2 and acceptor atom will be minus 2. For example, suppose I have it like this and coordinate bond is shown like this. So A is contributing its electron pair, 2 electrons it is contributing to B, such that those electron pairs are shared by A as well as by B. That is coordinate bond. So oxidation number of A will be plus 2 and oxidation number of B will be minus 2. Because A is donor. What is A? It is donor. And what is B? B is acceptor. B is acceptor. This is third rule. Oxidation number, next rule, of all atoms of different elements in their respective elementary states is taken to be 0. If the atom exists in elementary state, oxidation number is 0. Elementary state means what? You take N2, you take Cl2, you take H2, you take P4 elementary state, you take S8, sulfur elementary state it is, you take Br2, you take sodium, you take iron. So these are all elementary states. You take gold, silver. Yes, so all of them elementary state. Yes, elementary state, if they are present, then oxidation number is 0. Oxidation number is 0. Next point, the oxidation number of a monoatomic ion is same as the charge on it. So Na plus is there. What is the charge? Plus. So oxidation number is plus 1. Mg plus 2 is there. What is the charge? Plus 2. So oxidation number is plus 2. Then Al plus 3 is there. What is the oxidation number? Plus 3. Similarly, you have Cl minus. What is the oxidation number of Cl minus? It is minus 1. You have O2 minus. What is the oxidation number? Minus 2. You have N minus 3. What is the oxidation number of nitrogen? It is minus 3. So charge on the cation is its oxidation number. Charge on the anion is its oxidation number. Okay. Now, very important from here, please pay attention. The oxidation number of hydrogen. Okay. It is plus 1 when hydrogen combined, when it is combined with non-metals. For example, in H2S, oxidation number of hydrogen is +1. In H2O, oxidation number of hydrogen is +1 because these S and O are what? They are nonmetals. Similarly, oxidation number of hydrogen is -1 when it is combined with metals. For example, if you take sodium hydride, oxidation number of hydrogen is -1. See, with metal. If you take lithium hydride, LiH, oxidation number of lithium is -1. I'm sorry. Oxidation number of hydrogen we are speaking here. Oxidation number of hydrogen is -1. Okay. Then example, magnesium hydride you take, MgH2. Oxidation number of hydrogen is -1. Understanding? So if hydrogen is combining with a non-metal, then its oxidation number will be +1. If the hydrogen is combining with a metal, then its oxidation number will be -1. Yes. Similarly, we have oxygen. Oxidation number of oxygen is -2. Is what? -2 in most of its compounds. In peroxides, if you take peroxides like hydrogen peroxide, H2O2, then if you consider barium oxide, yes, so in peroxides, it is what? It is -1. It is -1, BaO2, -1. So in most of the oxides, it is -2 only. But in peroxides, it is -2. But if this oxygen is combining with, halogens, say most electronegative halogen, that is fluorine, to form, let me say, a compound of OF2. The oxidation state of oxygen here, oxidation state of oxygen is +2, students. It is +2. Understanding? It is +2. It is due to the fact that fluorine is most electronegative. Therefore, fluorine is going to have how much oxidation state? -1. Therefore, oxygen oxidation state is +2. Further, next point. See, these are very important points. We can calculate oxidation numbers if we know standards. In compounds formed by union of metal with non-metal, the metals will have, so metal plus non-metal is there. So let me say M represents metal, E represents non-metal. Then metal will have positive oxidation state and non-metals will have negative oxidation state. Yes, for example, oxidation states of lithium, sodium, potassium, and calcium, magnesium will all have what charge? They will have, this will have +1, this will have +1, +1, +2, +2. So it is positive for metals. Non-metals like chlorine, fluorine, bromine, then oxygen, they will have what? They will have -1, -1, -1, -2 like this. So metal will have positive charge, non-metals will have negative charge. The oxidation number of halogens. Which are our halogens? Fluorine, chlorine, bromine, iodine. It is always -1. It is always -1. Yes, in metal halides. Like if you have KCl. So it is what? Oxidation number of chlorine is what? It is -1. KF, oxidation number of fluorine is -1. Magnesium bromide, oxidation number of bromine is what? -1. Yes, in compounds formed by union of different elements, the more electronegative atom will have negative oxidation state, whereas more electropositive atom will have less electronegative atom will have positive oxidation state. Example. So what does this say? Electronegative atom will have negative oxidation state. Less electronegative atom will have positive oxidation state. Example, if you take NCl3, so which is more electronegative? It is nitrogen. So nitrogen will have negative oxidation state, whereas chlorine will have positive oxidation state. Correct? So nitrogen is more electronegative than chlorine. No, chlorine is more electronegative. Therefore, chlorine will have negative oxidation state. Nitrogen will have positive oxidation state. Yes? Okay. Further, few more examples here. We can take example like nitrogen is given oxidation number of -3 when it is bonded to less electronegative atom, say NH3. In case of NH3, nitrogen is -3. In case of Ni3, nitrogen is -3. Correct? But it is given oxidation number of +3 when it is bonded to more electronegative atom, as in case of NCl3. So this becomes plus nitrogen, this becomes minus. Understood? So here hydrogen will have plus, iodine will have plus, but with chlorine, nitrogen will have plus and chlorine will have minus. Since fluorine is most electronegative element, yes, its oxidation state is always -1. Its oxidation state is always -1. Yes, that is oxides, interhalogen compounds, always -1. Yes, in interhalogen compounds, that means between two halogens, when we speak, the more electronegative atom will get oxidation number of negative and less electronegative atom. Like for example, I have ClF, which is more electronegative, fluorine. So this will have minus, this will have plus. BrCl2, BrCl, let us say, which will have negative -1, this will have +1, because bromine is less electronegative than chlorine. Is that right? One more example, BrCl3 I have. It is interhalogen compound. Oxidation number of Cl is how much? It is -1, because chlorine is more electronegative. Oxidation number of Br is +3. It is +3. Okay. For neutral molecules, if you consider neutral molecules, this is very important. For neutral molecules, the sum of the oxidation numbers of all atoms is equal to 0. Sum of oxidation numbers of all atoms is equal to what? It is equal to 0 for neutral molecules. Example, I will give you neutral molecule NH3. Now, the sum of oxidation numbers of all atoms. So, nitrogen oxidation number is what? It is -3. Plus, hydrogen oxidation number is what? +1 into 3 is equal to how much? -3 plus 3 gets cancelled and it becomes 0. Yes. If you take complex ion, the sum of the oxidation numbers, will be equal to charge on the ion. Charge on ion. For example, SO4 -2. So oxidation state of sulfur and 4 oxygen atoms, it will be equal to -2. That will be equal to -2 because the charge on the ion is -2. Yes. So when you are finding it may be noted that oxidation number is always frequently called oxidation state also. You need not get confused, as I said. So H2O, oxidation state of hydrogen is what? +1. Oxidation state of oxygen is what? H2O. This is +1. This is -2. Okay. In case of representative elements, oxidation number of the element is same as its group number, while highest negative oxidation number will be 8 minus the group number. We have discussed this when we were discussing periodic classification. Periodic classification. Okay. So oxidation number, it differs. Now, how to calculate the oxidation number? So this is all the rules which are assigned. If you know the rules, it is easy to calculate the oxidation number. So prediction, you can say, or calculation of oxidation number. So there are some rules. I will explain the rules now. Then the examples on it we will take up in our next class. Okay, let us see what are the rules. By understanding all these concepts, students, okay, let me recapitulate the concepts only so that we'll take up the rules only in the next class. So oxidation number is what? It is the charge on the atom produced by losing electron or gaining electron. That is oxidation number. You can call it oxidation state also. And what is valency? Combining capacity. And we know the differences between oxidation number and valency. Rules of oxidation number for determining the oxidation number. First is that how to name it. When you have same elemental ion with the two different oxidation numbers, the lower oxidation number is added the suffix with OUS, and higher oxidation number is added the suffix with IC. For example, Fe plus 2 becomes ferrous, Fe plus 3 becomes ferric. Okay. Then second rule is that, what does the second rule says? If there is a covalent bond, so we will go to the rules here. If there is covalent bond between two same atoms, then oxidation number of both the atoms will be 0. Cl2 0, H2 0, O2 0, N2 0. But if the covalent bond is between two different atoms, then more electronegative atom will have negative oxidation number and less electronegative atom will have positive oxidation number. In case if there are multiple bonds, then they will be written as plus 2 minus 2. More electronegative atom minus 2, less electronegative atom plus 2. If it is a coordinate bond, the donor atom will get plus 2 charge and the acceptor atom will get minus 2 charge. If the elements are in elementary state, if the atoms or molecules are in elementary state, oxidation state is 0. Suppose I write N2 plus H2. Oxidation state of N2 is also 0. Oxidation state of H2 is also 0. Elementary state we call it as. And here are the examples. Na plus H2. Na oxidation state is 0. H2 oxidation state is 0. Okay. For cations, what is the charge carried by the cation is its oxidation state. For example, Al is plus 3, so it is oxidation state is plus 3. Barium plus 2, oxidation state is plus 2. For anions, the charge carried by anion is its oxidation state. Sulfur minus 2, so it is minus 2 only. Nitride, it is written as N minus 3, it is minus 3 oxidation state. In hydrogen, oxidation state of hydrogen is plus 1 when it is combined with non-metals. H2S, H2O, H2AC, oxidation state is plus 1. If this hydrogen is combining with a metal, then it is called hydride, students. What it is called? Hydride. And in case of hydrides, the oxidation number of hydrogen is minus 1. Minus 1. Oxygen. Oxidation number of oxygen is always minus 2. But in case of peroxides, it is minus 1. H2O2, BaO2, these are peroxides. So it is minus 1. KO2, peroxide, minus 1. Okay. Then, so oxygen, if it is combining with halogen, oxygen will have plus 2 charge because fluorine, not halogen, if it is combining with fluorine, because fluorine is more electronegative, so fluorine will have minus 1 charge and oxygen will have plus 2. Metal and a non-metal, if there is a compound with metal and a non-metal, then metal will have plus charge, non-metal will have minus charge. For example, calcium plus 2, rubidium plus 1. Similarly, non-metals will have minus charge. Oxygen minus 2, nitrogen minus 3, bromine minus 1. All halogens will have minus 1 charge. All halogens will have minus 1 as the oxidation state. If it is if there is a bond between electronegative atoms, there is difference in electronegativity. Most electronegative atom, it will have negative oxidation state. Less electronegative atom will have positive oxidation state. Example, if you take NH3, Ni3, nitrogen is more electronegative, so it will have negative oxidation state. Whereas if you consider NCl3, chlorine is more electronegative, therefore nitrogen will have plus 3 state. Fluorine being the most electronegative element, oxidation state is always minus 1. In any of its compounds, oxidation state of fluorine is always minus 1. In case of interhalogen compounds, also fluorine is minus 1. And it depends. Other than fluorine, if any other interhalogen compounds are there, more electronegative atom will have minus charge, less electronegative atom will have plus charge. Correct? Neutral molecules, sum of oxidation numbers of all atoms should be equal to 0. If you have ions, whether it is a cation, polyatomic ion and polyatomic cation, we say. SO4 minus 2 is a polyatomic anion. NH4 plus is a polyatomic cation. CO3 minus 2 is a polyatomic anion. In that cases, the sum of the oxidation numbers of all atoms will be equal to the charge carried by that polyatomic ion. Charge carried by that polyatomic ion. So with this, I hope you have understood with all the concepts. Calculation of the oxidation number, how to calculate the oxidation number, we will proceed in our next class. Hope you have understood everything properly. Please practice them so that it helps us for calculating oxidation numbers, and we'll take ample of examples based on that also. For now, thank you.